Welcome to Global Education Services. In this video, we will talk on SN2 reaction mechanism. Before looking at the mechanism, we shall learn some basic concepts such as the nucleophile and the nucleophilic substitution reaction. A nucleophile is an electron-rich species which donates an electron towards electrophilic compounds. Certain nucleophiles are neutral in nature and certain nucleophiles are negatively charged molecules. Looking into the nucleophilic substitution reaction, it is a reaction in which a nucleophile will donate a pair of electrons towards an electrophilic carbon atom containing a living group, in which a nucleophile will replace a living group, resulting in a substituted organic compound. Coming back to the SN2 reaction mechanism, here SN2 indicates a substitution nucleophilic bimolecular reaction, which is described by means of an rate expression in which the rate of a reaction depends on the concentration of both the nucleophile and also on the living group. The molecularity of this reaction is considered to be the 2 because the rate determining step involves an interaction between the two species such as the nucleophile and also the organic substrate. The energy profile diagram is a plot of energy along y-axis and the reaction coordinate along x-axis. It indicates the energy of the transition state which has been formed during the reaction mechanism. Reactants in a higher energy state, whereas the transition state at the highest energy level, which is highly unstable. The energy profile diagram accounts for the instability of the transition stage and the products at the lower energy level. We shall learn the SN2 reaction mechanism by taking an example of a reaction between the methyl chloride, the nucleophile base such as NaOH to form methanol and sodium chloride. In this reaction, the nucleophile, that is the hydroxyl group, will donate a pair of electrons from the oxygen atom, which is electron rich, towards an partially positively charged carbon atom, which is bonded to an partially negatively charged chlorine atom. This reaction proceeds via formation of an unstable transition state in which carbon atom has 3 complete bonds and 2 partial bonds. This step indicates the simultaneous bond making and simultaneous bond breaking. And after the removal or the loss of the halogen atom, halogen ion, the alcohol will be obtained. This type of reaction mechanism is considered to be a concerted mechanism as it explains the reaction in a single step involving a transition state. Looking at the stereochemistry of SN2 mechanism, it proceeds via inversion in configuration because the nucleophile attacks the carbon atom in the direction opposite to that of the functional group or the living group. And hence, it results in an inversion in the configuration. Studying the solvent effect on this SN2 mechanism, basically the polar aprotic solvents will enhance the rate of a reaction for SN2 reaction mechanism. because these solvents will not solvate the nucleophile. The unsolvated nucleophile possesses higher energy and it helps in enhancing the rate of the reaction. So, SN2 reaction mechanism basically occurs at a faster rate with respect to the alkali metal hydroxides, with considering a basis which is a strong nucleophile, and also with an